So in order to find the following angle measures with regard to this circle, I need to take a look at what type of angles that I have. And the first one's asking me for angle ABE. That is the same thing as angle ABD. I see that its vertex is on the circle, so it's inscribed. It intercepts arc AD, therefore it's 1/2 the measure of that arc. So 120 divided in half is 60 degrees. I also have another inscribed angle that intersects the same arc, AD, so that's also 60 degrees. So now all I have to find is angle ACD or angle DCA and fill that in also. And that's the next one. So now I need to find angle BAE. And as you can see, if I highlight BAE, that's the same thing as BAC. That intersects arc BC. So that angle is 1/2 40 degrees. So this is 20. Angle DCE is the same thing as DCA. So we had already found that to be 60 degrees. And angle BEA, since I have a triangle here, and I have two angle measures, all I have to do is use their sum, subtract it from 180, and I get a difference of 100. And angle CED is also 100 degrees because we had found this angle measure, and you have vertical angles are congruent right here, so this is also 100. So angle CED has a value of 100 degrees. So the next theorem we are going to work with is the tangent and chord angle theorem. And what we want to be able to do is define and identify tangents, chords, and their angles created inside of a circle. And we want to apply the tangent and chord angle theorems in order to find angle measures and their respective arc measures. So here's what it looks like. Here's our chord, and here's our tangent. And it has the same property as an inscribed angle because, as you can see right here, the vertex is on the circle. And it intercepts this arc, which is 140 degrees, and we're going to take 1/2 of that. That makes this angle measure 70 degrees. Okay, so when a tangent meets a radius at the point of tangency, it forms a right angle. So this is an important theorem to know. Okay, so we're not dealing with a chord, we're dealing with a radius, and we know that has a right angle when it meets the tangent. If you have two tangents from the same external point, they are congruent. So it's always an isosceles triangle base. Angles are going to be equal because we have two congruent sides. Okay, here's the congruency. That means these two angles are congruent. So we can fill in the blanks here because we have a few tangents. These two are the same tangent, so that means this question mark is equal to 5. These two are the same tangent, so this is equal to 6. And this is tangent with this, so this is equal to 10. As you can see, all radii are congruent in a circle. So here's two radii. They're each given a length of 15, so I know this is also 15, and I know this is also 20 because tangents coming from the same external point, in this case it's R, have the same value. And I could also draw an altitude here and get two congruent triangles. If I needed to find the length of this side, since I have two of the sides of the triangle, all I have to do is use a squared plus b squared equals c squared, the Pythagorean theorem. I have the length of two sides, so 15 square plus 20 square is going to give me the hypotenuse square. And we know that it's the hypotenuse because it's across from the right angle. So 225 plus 400 is equal to c squared. That means c is equal to 25 because we have to take the square root of both sides in order to reverse the process of squaring a number. Okay, you're responsible for the associated work that I will be providing to you in class. That must be completed in class and handed in.